Welcome students. In this class we will learn how to solve this Olympiad geometric question. We have a triangle. I'm drawing the triangle. It's a right triangle and this is A, this is B, this is C. Now there is an angle bisector which is AQ drawn in such a way that AQ bisects A, and it is given that AQ is equal to 9. Now there is also another angle bisector which bisects C, and that is PC. Now it is imperative to understand when we say bisector, it bisects, it's nothing but a line or a ray which divides the angle into two equal parts. Say for example you got 60 degree at A, then if I were to have an angle bisector, then 60 degree would be divided into two equal parts, 30 degree and 30 degree. Have that in mind. So these two parts are equal. That's an important understanding. And similarly these two parts are equal. Okay. It is also given that CP is equal to, CP is also an angle bisector which is bisecting C. So in other words, this angle and this angle will be equal. So CP is given to be as 8 times the root of 2, and we are asked to find AC. Now this is a right triangle. Okay, this is a right triangle, and that makes everything simple because we can use trigonometry. Now what I wish to do is, if I were to take this division to be as theta, then this would also be theta. Now if I were to consider ABQ triangle ABQ, then I can actually apply the trigonometric ratio. Let me draw that triangle. So this is going to be the triangle, and this point is B, this point is Q, this point is A, and this point is theta. Now we can take it as theta or alpha or beta, anything that we want. I'm taking it as theta. So let me use the law connecting cosine. So I want to get the trigonometric ratio involving cos. Now if I were to take cos of this theta, then that would be the adjacent side divided by the hypotenuse side. Now what is the adjacent side? AB. What is the hypotenuse side? AQ. So this would mean I can rewrite AB to be as A times Q times cos theta. But AQ is given to be as 9 units. So this is going to be 9 times cos theta. So therefore I now have equation AB being equal to 9 times cos theta. So let me take that to be as 1. Now this is 90 degrees. Now some of the angles should give us, inside the triangle, should give us 180. So if this is 90, what would this entire angle be? This is going to be 90 negative this. So angle at C is going to be 90 degree. When I talk about C, I am talking about this entire angle. 90 minus, take away this angle, This angle is nothing but theta positive theta. That's going to be 2 theta. So this is going to be angle at C. But if I were to consider, let me consider triangle PBC. Then this would be 45 degrees negative theta and this would be 45 negative theta. Let me use a different color. This is going to be 45 negative theta and this is going to be 45 negative theta, isn't it? 45 negative theta added with 45 negative theta will give me angle at C, which is 90 degree negative 2 theta. That's perfect. Now what we can do is we can again consider this triangle and apply the law of cosine. So let me do that. So this is going to be 90 degree B, P and C. This is going to be 45 negative theta. So the ratio involving cos is going to be cos of 45 negative theta is equal to, the adjacent side is BC and the hypotenuse is PC. So this would mean BC divided by PC or CP. What is the value that's given? That's equal to 8 into root 2. So 8 into root 2 is given. So from here I can write, therefore BC is equal to 8 times root of 2 times cos of 45 negative theta. Fine. Okay, so let me take this. I've taken this as 1. I'm going to take this as 2. Now let me consider the entire triangle. Now consider triangle ABC and I wish to take, let me draw this triangle. So this is my A and this is my C. This is my hypotenuse side AC and this is B. So I wish to take this entire angle to be 2 theta, right? So this entire angle would be 2 theta because this is theta, this is theta, theta added with theta is going to be 2 theta. Now let me take the trigonometric ratio involving tan. So tan of 2 theta is going to be equal to opposite side divided by adjacent side. What is my opposite side? BC. What is my adjacent side? AB. So you got BC over AB is equal to tan 2 theta. So that looks nice. So I can rewrite this as tan 2 theta is equal to BC over AB. Now we know a very important formula involving tan of A positive B is equal to tan A plus tan B divided by 1 negative tan A times tan B. Now in this case we got, in place of A we got theta positive theta. So this is going to be tan theta positive tan theta. This is 2 times tan theta divided by 1 negative. A is theta, B is theta. Tan theta times tan theta is going to be tan squared theta. So this means I can write 2 theta as, in place of tan 2 theta, this is going to be the case. So therefore BC divided by AB is equal to 2 times tan theta divided by 1 minus tan squared theta. So this is going to be my 3. Now I got 2, I got 1. Now I'm going to use this space here. So let me use the space here. Consider 2 divided by 1. So what is that equal to? What is 2? 2 is this, BC. Therefore we have BC divided by AB is equal to, BC is 8 times root of 2 cos of 45 negative theta divided by AB. AB is going to be 9 times cos theta. So this is what we've got. Now what I wish to do is I would like to use cos of A minus B. That formula. We know that cos of A negative B is equal to cos A cos B. This is negative, so this will be positive. Sin A sin B. I am utilizing this formula. So this is going to be 8 times root of 2 times cos 45 times cos theta. Negative means positive, sin 45 times sin theta divided by 9 times cos theta. So this is equal to 8 times root of 2. Cos 45 is 1 over root 2. This is cos theta plus sin 45 is 1 over root 2 times sin theta divided by 9 times cos theta. I am taking 9 like this, 8 over 9, and 1 over root 2 can be taken out. If I were to take 1 over root 2, 1 over root 2, that would get cancelled with this root 2. So now I only have cos theta positive sin theta divided by cos theta. Now I can rewrite this as 8 over 9. I am going to divide by cos theta. So this is cos theta over cos theta. It's going to be 1 positive sin theta divided by cos theta, which is equal to 8 over 9, 1 positive. Sin theta over cos theta is going to be tan theta. This is nothing but BC divided by AB. But I already have a BC here in 3. So if I were to take this as 4, I can equate 4, I can equate this part BC over AB 4 with the 3, right? So let me go to the next page and do that. So I'm writing it down here, equating 4 and 3, or 3 and 3 or 4. So what do you have here? 3 BC over AB. So BC over AB. So that's going to be 2 times this part. I'm writing this part, 2 times tan theta over 1 negative tan square theta is equal to 8 over 9 of 1 positive tan theta. 8 over 9 of 1 positive tan theta. Now let me take, I need to solve this, right? To solve it, let tan theta be equal to some t, so that I will get the algebraic field. So this is going to be 2 times t divided by 1 negative t squared, 8 over 9 of 1 positive t. I'll cross multiply. I'll use this part of the page. So it's going to be 18 t is equal to 8 times of 1 positive t. I'll move this to the other side. So it's going to be 1 negative t squared. So you got 18t, 8 times, you distributed 1 into 1, 1 into negative t squared, t into 1, t into negative t squared is negative t cubed. This can be rewritten as 8 negative 8 times t squared positive 8 times t negative 8 times t cubed is equal to 18t. Move this, or you bring everything. This is a cubic equation. Bring everything to the left. So it's going to be 8 times t cubed positive 8 times t squared. Now this is going to be minus, right? If this comes on this side, it's going to be negative 8t added with positive 18t will give me positive 10 times t negative, if this 8 goes to the other side, is going to be negative, is equal to 0. Now what I can do is I can actually divide by 2. Let me divide by 2 throughout. So this is going to be 4 times t cubed plus 4 times t squared plus 5 times t. Negative 4 is equal to 0. Now what we will use is we will be utilizing the rational root theorem. So what exactly is the rational root theorem? You take the factors of 4. It's actually negative 4. So that's going to be plus 1 or minus 1, plus 2 or minus 2. And you got plus 4 or minus 4. So these are the factors of this guy, this quantity. Now you take the factors of the leading coefficient, that's 4. The factors are plus or minus 1, plus or minus 2, plus or minus 4. So these are the factors. Now what you do is you take the combination of the numerator divided by the denominator. So 1 can be divided by 1. 1 divides, in other words, 1 over 1, 1 over 2, that's also a factor. It's plus and minus, right? And 1 over 4 is also a factor, a possible factors for this particular equation. So that is the understanding, a possible factor for this entire system. So plus or minus. Now similarly, 2 divided by 1, do we have 2 divided by 1? No. So plus or minus 2 divided by 1, it's same as 2. And then 2 divided by 2 is there, that's nothing but plus or minus 1. 2 divided by 4, that's there, plus or minus 1 over 2, right? Similarly, 4 divided by 1 is not there, so plus or minus 4 you need to place. 4 divided by 2, it's 2, plus or minus 2 is there. 4 divided by 4 is 1. So therefore the possible factors for, say, I'm taking it as 5, for 5 are plus or minus 1, comma, plus or minus 1 over 2, comma, plus or minus 1 over 4, comma, 1 over 4, comma, plus or minus 2, and then plus or minus 1 over plus or minus 4. That's it. So these are the possible factors. So what you need to do is you need to substitute the values. But what I would do is, actually what you have to substitute these values and find out which is the factor. You can either do that, but what you can otherwise do is you can use synthetic division. Synthetic division. So it's actually trial and error. Now trial and error means you have to substitute these values and then you have to find out the factor. So you're trying, and error in the case, if it is not equal to 0, that's an error. So the value that you have chosen is not right. So go to the value and then you substitute it again and then find out. So what I can do is, if I were to substitute plus or minus 1, clearly I can see it's not going to work. You see that? It's not going to work because you will have a remainder which is not equal to 0. Now if you want to substitute plus or minus 2, let me substitute plus 2. So if I were to take this as, say, some p of t is equal to 4 times t cubed positive t squared positive 5t, you can take it as a polynomial. So let me do that. So this is going to be 4 times t cubed, 4 times t squared positive 5 times t negative 4, when t is equal to 1 over 2. So this is the substitution I'm doing. So p of 1 over 2, if this is equal to 0, then t is equal to 1 over 2 will definitely be a root. Now after we have found out the root, I will be applying synthetic division, or you can choose the method that you want. So let me go ahead and find out if it is equating it itself to be equal to 0. So this is 4 of 1 over 2 raised to the power of 3 positive 4 times 1 over 2 raised to the power of 2 positive 5 times 1 over 2 negative 4. This is 1 over 8. 4 divides 8, 1 over 2 times. This is 1 over 4, that's positive 1. This is 5 divided by 2 and negative 4. Now you got 1 added with 4, that's going to be negative 3. So you got a negative 3 added up with 1 over 2 added up with 5 over 2. So this is going to be, if I were to take the LCM as 2, this is going to be negative 6, positive 1, positive 5. You see, 5 added with 1 will give me 6, 6 added with negative 6 is going to be 0. So this is going to be 0. So therefore t is equal to 1 over 2 is a root. Now after getting it to be a root, what I will do is I will place it over here and I will apply synthetic division. I will take the coefficient of the variables that you see here. This is going to be 4, 4 and 5 and negative 4. I bring 4 down. Now you will understand why am I doing it like this. Just bring this 4 down and then multiply 1 over 2 by 4. that would give me 2. Add them up. 4 with 2 would give me 6. Multiply 1 over 2 with 6. That's going to give me 3. Add 5 with 3. That's going to give me 8. 8 multiplied with 1 over 2 will give me positive 4. So this is 0. That's fine. Now, whenever you apply synthetic division, the degree of the polynomial gets reduced by 1. So that is the reason I have now got the polynomial now. So this is nothing but the quotient is equal to 4 times t squared plus 6 times t positive 8. So this is the quotient. Remainder is 0. So no need to worry. So therefore, the p of t can now be rewritten as t is equal to 1 over 2 is a factor. So that would mean t negative 1 over 2 is t is equal to 1 over 2 is a root. So t negative 1 over 2 is a factor. And the other quantity is going to be 4 times t squared positive 6 times t positive 8. So this is what we've got. Now we need to obtain the values, right? So that would mean I'm equating it to 0. So this means t negative 1 over 2 times 4 times t squared positive 6 times t positive 8 is equal to 0. So this is equated to 0. Now either t negative 1 over 2 is equal to 0 or 4 times t squared positive 6 times t positive 8 is equal to 0. Why am I doing all these things? Because I need to get the values for the variables. That's the reason. Now if I were to simplify this, I'm going to use the quadratic formula. And if I were to use the quadratic formula, I can actually directly apply, if I were to directly apply, minus b is negative 6 plus or minus root of b squared is 36 negative 4 times ac, 4ac. So 4 times 8 is 32 and 32 times 4, right? So this is going to be 4 times 2 is 8, 128. So 128 divided by 2 times of 4. Now clearly you can see that the discriminant, you see that this is actually turning out to be complex roots. And we are not interested in complex roots. So this would mean t negative 1 over 2 is alone possible. And from here I can write t is equal to 1 over 2. But what is t? I've taken t to be as, this means tan theta is equal to 1 over 2. Now if you remember, we considered the triangle, right? We considered the triangle. This is the triangle we considered, right? And we got that value. So now it's time that we extract these values. So let's do that. Now I will use this triangle ABQ. So we know the value for tan theta, right? Tan theta is equal to 1 over 2. So this is 1 and this is 2. So AQ, we can extract the value for AQ. So AQ is nothing but, if I were to take this as some x, so x squared is equal to 2 squared positive 1 squared. 2 squared is 4 positive 1. That's going to give me 5. So x squared is equal to 5. Therefore x is going to be root of 5. This is the value for AQ. So I've got AQ. Now once I get AQ, we can extract the value for sine. Now what is sine theta? Now you might be asking, why do we need sine theta? Because we would have to utilize the value for sine theta over here so that we can get the value for BC. Now AP is also there, so I can also get the value for cos theta. Now cos theta can be easily extracted. So cos theta is equal to adjacent side, that's going to be 2 divided by hypotenuse. Hypotenuse has been obtained to be as root of 5. So cos theta is got. Now from here I can also get sine theta. Sine theta is equal to opposite side divided by hypotenuse root of 5. So all I need to do is substitute the values. So from here AB, if I were to substitute the value of cos theta, AB is equal to 9 times cos theta value 2 over 5. So 9 2s are 18 divided by root of 5. So I've got that value. Now over here I need to obtain the expansion. So let me just use this part of the page. So we got BC is equal to 8 times the root of 2 cos of 45 negative theta. I'm going to expand this. So 8 times root of 2 cos of a minus b, that's going to be cos 45 cos theta plus sin 45 sin theta. So this is going to be 1 over root 2 can be taken out. If I were to take that out, this and this and this, all these things can be cancelled, giving me 8 times of cos theta value. Cos theta value is this 2 over root 5. So 2 over root 5 plus sin theta value 1 over root 5. So this is going to be LCM is going to be root of 5. 2 added with 1 is going to be 3. So 8 3s are 24 divided by root 5. This is going to be the value for BC. So BC is equal to 24 over root of 5. Okay, let's go back to the triangle. I needed AC, right? So let us use the Pythagorean property. So AC squared is equal to AB squared plus BC squared. Now what is AB squared? AB is 18 over root 5. So this is going to be 18 over root of 5 square positive BC. BC is 24 over root 5. So 24 over root 5 square. I can actually add these things up. So let me just move to the next page. So AC squared is equal to 18 over root 5 squared positive 24 over root 5 squared. This is going to be 18 squared divided by 5 positive 24 squared divided by 5, which is equal to, I'm taking 5 as the LCM. So this is equal to 18 squared is 324, 24 squared is 576. So let me add these two together. 324, 576, 6, 10, 1, 10, 1, 900. So this is going to be 900 divided by 5. This is my AC squared, but I need only AC. So AC is equal to root of 900 divided by 5. So this can be evaluated. So what I will do, I will divide 900 by 5. That is going to give me 180. You got a square root there. I'm going to write 180 as 9 multiplied with 20. You got the square root there. Then I will rewrite this value as root of 9 times root of 20. I'm going to write it as 4 times 5. This can be rewritten as root of 9 is going to be 3. And you got root of 4 times root of 5. Root of 4 is going to be 2 times the root of 5. So this is going to be 2 times 3 or 3 times 2 will give you 6 times root of 5. This is going to be the value for AC. So that completes the solution for this question, students. I hope you enjoyed this. Have a good night. Thank you.